Hello there, welcome back to this channel. This is Tutor Buxton. Today I would like us to learn how to do an estimation for a septic tank using a software called Planswift, which we are basically going to use it to read the drawings. I just open the plan, the software. Here we are. So this is Planswift. When you want to open a drawing with it, go straight to new, the new file. Okay, once that is open, then at the job or quote you can describe what you need. For us, we are interested in doing septic today moment, so I go to next. This opens where your local files are located. Double click on where the drawing has been stored. You double click on that where the individual files are situated. So this is the one that I want. I will click on that, then next, then do again next, and next, then finish. So you'll give it time so that it opens up the particular drawing that you are wishing, that you hope to look into. So here we are. We have the drawing already opened here. So this drawing, today we are interested in the septic tank. So this is where we'll focus on. Once you have your drawing open, then the very first thing to do, go to scale, because you have to scale the drawing. So you can choose. One of them is in metric and the other one is in a different unit. So for us, we are going to use the metric dimensions. You click on the metric, and then you can choose on any of these dimensions that are written, so that you use it to read the rest. Okay, this is what we call the scaling. In other sense, you use what is known to scale the rest of the drawings. So I've indicated 0.8, which is basically this 800. So this is 0.8. I click OK. Then now you can zoom it in until it stretches completely, and then you do that. So the 0.8 is here. Just for a confirmation, you can click on the linear tab, so that you use it to confirm whether the rest of the points are in order, just to confirm. So this is 1.7 seems to be low. Let me check another one. 0.95, not really, just confirming. Yes, so that one looks in order. So once our drawings are confirmed in terms of the dimensions, and also note that if the drawings are of different scales, then you'll need to read them independently, because you can see here it's 1 to 100. Then the plan is also, being that it's not indicated, it's of the same dimension, of the same scale. Nevertheless, you can always confirm, so that you make sure that what you have in terms of the dimensions is correct. Now that is confirmed, our plan, our section, and the plan are all in one dimension. So quite fast, that is how to use Planswift to read dimensions. Then also you can use Planswift to get areas of different items quite fast. Okay. So for instance, go to the area tab, click it, and then say okay. After that, then you can stretch from any point of the plan that you need to work on. Like now I need to work on from that point. Okay. Then you just stretch it across along all the corners that you need to draw, to measure the areas. So I'm that point. All right, so if I need to get the plan for the entire section first, and then I get the other part differently, this is how I'll do it. Okay. All right, so that is 2 sections done. Then I also go to the other section, just that way, that way, that way. All right, so that gives me all the 3 sections complete. And you can see the area there is around 0.95 square meters. Here is 9.36 square meters. while this is 0.97 square meters. So in a nutshell, that is how you use Planswift to read that. Now, continuing with what we are doing today, which is the septic tank. So we are going to use Excel as usual because it's easier to use, and I can always use it to explain our work very fast. So the first area that I would like us to cover, or also just to remember, we are going to use or rely on standard methods of measurements as rules that is going to guide our estimation. It's worth noting that you consider that as well. So if you want to do estimation for a septic tank, then what you need to consider quite fast are the excavations. Now, excavations, when you need to know, it's in cubic meters, that is the unit. Okay, so the quantity that we are looking for is in cubic meters. Our calculations, we'll do them on the side here. All right. So the first excavation, let's see what we have in total. So this is D, and we also have other sections of it. So what happens, the reason why septic tank in most cases, you are being given the letters here, it's because the design can be constant, but then depending on the capacity of the septic tank you are dealing with, you can always choose or pick the length to adopt. Like in this case, we have two options here, option A, all right? We have option A and option B. So option A, you notice it's smaller because you can see the number of persons is 10, while option B, the number of persons is 20. Therefore, the dimensions for that is different. I would like us to take option B of 20 persons capacity of the septic tank. So that means our D in terms of the length is going to be 3.6 meters. So that is what we are going to use. Once that is noted, then for us to get the excavation volume now, of course, we'll get the length as usual, the width as well. You can see the width has been indicated. Let me just do away with all those highlights so that our drawing is clearer. All right, so we have that. So we've seen this, the D is 3.6. So what we'll do next is getting the excavation. So you can always do this excavation depending on the sections, because you realize that we have manholes on either side. So inlet manhole 1 and also another outlet manhole. So, but then those two sections, they are not of the same depth as the other one. So you can do it in two ways. So option 1, take the first bigger portion, okay, the portion that has the dimensions F1 and F2. So consider that first, and then you consider the manholes separately. That is the best or the preferred way of looking at this. So on the main section, we've seen D is 3.6, okay? So starting from this end, we'll take, so looking at the section, you notice there is a stretch, there is an extension here, which we'll have to measure because it's not indicated. We'll have to measure for the slab so that we know what it is. So that one is around 1. We'll do, let me just zoom it in well so that I can read it properly. So we'll take 165 as an extension that side. And also, let's also see this one here. This is also, this other side will take 230. Yeah, they don't seem to be uniform. So we'll just read and adopt what is here. So we'll take on the first stretch is, so what we can do here, we get the length of the septic tank for the main portion for the excavation. So it's equal to, so we have 165. I can say 0.165. Then we add to 0.2 is the wall, okay, this part here. And then now we've read D to be 3.6 according to this provision. D is 3.6, so we add 3.6 there, and we also add another 0.2 for this, and the stretch or the external spread on this particular portion. So we add 0.2, and we also add 0.23. Okay, so that gives us the total length of the main section of the septic tank for the excavation works. And then we also work on the width. Width here becomes width has been indicated. So what we have to check is it's 1.8. 1.8 is within within the walls. So that is how it is. The 1.8 is here. So we'll have to add the walls to the 1.8. So 1.8, then we add 0.2 times 2. All right. So what we also need to take keen attention on is that there is no section of this that is cutting this way provided. So what we need to do is to give an allowance for external excavations or excavations beyond the wall. Okay, so we'll have the 1.8 plus 0.2 times 2. Then we can take 0. Let's take the bigger one, 0.23, just equivalent to what we've read in section AA. And then this we multiply sorry, we multiply by 2. Okay, so we have width of that. Then the next discussion is for the depth. We get the entire depth first, and then now we'll subdivide it into the sections or into the stages according to the rule of stages of 1.5 meters deep. So the depth, total depth, let's see. You notice that the septic tank is slanting, okay? Because at this end, where my cursor is indicating, this portion here, you notice it's shorter than the depth of the portion that is indicated F1. Okay, so what that means is that you need to get an average at the end of the day so that you get the average of the depth. So what we'll do, there is a common line here, okay, where it's indicated TWL. There is a common line there, and then there is an F2 and an F1. Okay, so it's going to be an average. So what you do, F2 and F1 have not been indicated, so we go again to this table. Okay, this table we took preference B for the capacity of the septic tank. So F1 here is 1.5 meters and F2 is 1.4 meters. So for those two that have been indicated are the ones that 5. So we have 1.5 plus 1.4. Okay, so of course the base for the slab is common. So these two are the ones we are going to get the average. So we take those two, divide by 2 so that we get the average for that. And then now we'll add this, we'll add the depth for the base of this particular septic tank. And as we mentioned, we adopt the Planswift to do our measurement here. So this one is let me take it quite keenly. Just go back to the linear dimension from here to this point. All right, so that gives us 200 in the depth of the base. So we have here 0.2, and of course we are going to add a dimension or a thickness for the blinding, which is normally 0.05 for blinding. and after that, now the dimension that is above the line, okay? Because you notice there is an existing ground level here, which includes the dimension above the line, okay? So we check if it's indicated. If not, then we'll measure. So the dimension above the line doesn't seem to be here. So what we'll do, we'll measure it. So I'll just take my linear tool up here, okay? From the linear tool, I put it there from that line to where I need it up to the soffit of this particular slab, okay? Let me just stretch so that you can see. Okay, so I'll take that to be 750, okay? Because you can see the GL stands for ground level. So from the ground level out to the line that we had not taken is equivalent to 750. And that one is common, so I'll take 0.75. Again, I get 2.45 in total depth of a septic tank. So we already have the total depth. So what we'll need is simply to get the first stage of the excavation works. Okay, so the excavation stage 1. So that is what we need. So we get length times the width, and then times the depth. So depth we take first 1.5, because the rule mentions that you measure in stages of 1.5. So I get the first 1.5. That is what I get. And also, it's important to remember that for the first stage, we need to add the excavations for the manholes as well. Okay, so the manholes that we have, they are indicated here. Okay, the length is 0.8, but then you add the 0.2. Okay, so we'll have here 0.8. Okay, of course, there is an allowance that we gave for excavation of the septic tank at the main one. So that stretch should cover us for what is here. So of course it's mine. We'll take 200. Okay, from this point up to this point, we less 200 and then we add the 200. So it's like -1 plus 1. So this remains to be 0.8. And then the width is 0.6. But then we add the wall parts. So it's 0.6 plus 0.2 plus 0.2. So that gives us 0.6 plus 0.2 times 2. So we have 1. Then onto the section where we are going to get the depth. How do we go about that? So you can see we'll measure from here to here. We had actually measured, and the dimension was the measurement was 0.75. 0.75, but we need to add the 200, because the 0.75 is up to the top of the base slab for the manhole. So here we do equal to 0.75, then we add 0.2 for the base slab, we get 0.95. So the stage 1 of the excavation here comes to be times width, then times the 0.95. Okay, so stage 1 we have it here. We get the total of that. It's that one plus this, we get 18. Okay, but then there is the excavation stage 2. Okay, so for the stage 2, we are going to now do the same length, then you multiply by the width, then you multiply by whatever is left of this. Okay, so what we'll do, bracket, this is 2.45 minus 1.5, which was done in stage 1. Okay, so that is what we get. It becomes to be 11. Then for the manholes, there is not another stage, because it's just the total was 1.5, which is the total of which is the entire excavation depth to be considered. So we get this is 18, while stage 2 is 11. All right. Okay, so all that considered, we come to our excavation volumes. So stage 1, we've already done our volume. It's 18 cubic meters for stage 1. Quantity is 18. Okay. Stage 2 is from what we've calculated. Stage 2 gets to be, I believe we do it this way so that we can round up. Okay, so this one is 19. We take 19 for stage 1 and 12 for stage 2. Okay, so we take this to be 19, while this one for stage 2. It's always advised that you round it up to the next whole figure. Then the next item is load and cut away surplus spoil. All right. So normally, depending on the type of soil which you're dealing with, if it's black cotton, it normally compromises the structural stability of any structure that you build on it. So it's always advisable that you cut it away. So in this case, we are assuming it's going to be a black cotton soil. So we are intending to cut away all the excavated materials from site. So we add the 2. Then 50 thick millimeters ground base slab. This is now for mass concrete blinding. For the blinding, we always do it in square meters. That is what you can see in the unit. So after the square meters, then you now need to know what do you have in terms of the length and the width. So the blinding we are dealing with here, it's calculated for both main section of the septic tank and also on the manholes. Okay, so we had already calculated the dimensions which we are going to stick by. So it's that one there times width now becomes to be that still. All right, so that is what we have. And then yeah, so that is what we have for the area for the main section. And then we also do the area for the manhole section. So that one becomes 0.8 multiplied by 1. So that is 0.8. So we add the 2 so that we do the workings together. So that gives us 12.49 square meters. So the total of that is 13 square meters for concrete blinding. The next item we talk about is the structural concrete components. So the first of which is a ground base slab, and then the next one is the suspended slab, that is the cover, and then we have a dividing wall and a scam baffle wall. Okay, so it's also important we know which is which. Ground base slab is the one that is in the surface of the in contact with the earth. This is the ground base slab, the one at the bottom, while the suspended slab, of course, it's this one at the top. And then dividing wall, it's this one here. Okay, the one from the base slab all the way up to some point where the one my cursor is moving about. And then scam baffle wall is this shorter one. Okay, so that said, we go straight into our estimation. So the ground base slab, it's the entire stretch. Okay? So we need to confirm the thickness. So we had measured the thickness and we noticed it's 200 millimeters. So the square meters that we need is basically equivalent to the blinding that we had already calculated. But then the same applies for the manhole. So the addition we had calculated up for the blinding is going to remain the same as 13 square meters. Then the next is 125 millimeters thick suspended slab, which you can see this is 125 millimeters thick. Okay, so this is the floor plan, but what we need is the area for the septic tank cover slab, the entire of it. Okay, so looking at these, we have for the manholes are going to be considered under covers. Okay, so what we calculate using the Planswift, go to the area. Okay, this is the Planswift. Under home, move to area, click on that, then click on OK. After that, put your cursor on any part of the exterior end of what we have as the drawing. Then you drag it to all the corners, to that corner, and then you come to this corner as well, up to where you started. Then it's enclosed. Then you click stop. After that, you can read the area indicated there. That is 9.39 square meters. So once you have that, then we round that to the nearest whole number. So 9.39 to the whole number is 10 square meters. So that becomes 10. Then 100 millimeters thick scam baffle wall. So what we do, the scam baffle wall, according to this section, it's this one here. Okay, I hope you can see where my cursor is playing around. So this one here, it's this, the same wall. So we measure it. It's always important that we measure it up to you can see there's a smaller portion of it that is going into this wall. Okay, so you can take it halfway. So you go to the linear, take the linear tool, click on it. Okay, then you can take half of this wall from this point, then you stretch it down, hold on shift so that it's straight without having to dangle and disturb you. Then you click to the tip where you need it to stop. All right, then you just move your cursor around and you have that linear dimension reading. So you can see that 1.99. So let's take it to be let's take that to be 2 meters. Okay, so the unit of measurement is square meters. What I'll have is now 2 meters for the length, and then what do you have for the height? Height is 0.5 meters. All right, so that gives us 1 square meter for the scam baffle wall, and then 100 millimeters thick. Actually, this is a dividing wall. So for the dividing wall, no, the one we have done is the scam baffle. So let's just have it here. And then we also talk about measure the dividing wall. So our dividing wall is this one. In reference to the section, you can see the section here. This is the dividing wall, while at the top is also the dividing wall at this point. So their lengths are the same. The length of the scam baffle wall and the dividing wall are typical. So we'll take the unit of measurement is square meters. So we'll take the 2 meters as the length. So is equals to 2 meters multiplied by the height. Okay. So the height of this particular dividing wall, how do you go about that? We can measure using our Planswift. Go to linear tool as well, click OK. Then from where it starts, go all the way up to where it stops. Okay, so we have it here. All right, then you click stop. We can use this. Now what do we have? 1.95 meters. So I take 2 meters for the length and then 1.95 meters for the height. That gives me 3.9 square meters. I will take 4 square meters rounded up to the nearest whole number. Then quickly, straight away, we go to reinforcement bars for the septic tank. Normally, when you're looking at these, reinforcement that we are going to consider here is for the base slab, okay? And also, there is a reinforcement that is supposed to be done for the top cover slab. So for the base slab, we are going to use the thumb rule to do our assumption in the reinforcement bars. So normally, structure of this nature, the kgs per square meter for the entire stretch or for the slab is normally around 12 to 15 kgs per square meter. So that is what we are going to use to make our assumption. So we go to the area for the cover slab. Cover slab is this is the cover slab. It's 10 square meters. So what we'll take, let's take the 15 kgs per square meter. So it's 15 multiplied by the area of the suspended slab, which is 10. So here we get 150, but then instead of now subdividing to 15 specific diameter of reinforcement bar, we'll say assorted reinforcement bars, which means the designer can either decide it will be 8 or it will be 10, depending on what will be decided later on. You should be safe with that assumption. So this one comes to 150 kgs. This is for the suspended slab, okay? But then now for the ones that we have as the base slab, for both the main section and the manhole sections, we are going to use fabric mesh reinforcement bars, okay? So that is equivalent to the areas that we've already calculated. So in this case, the unit of measurement is square meters, okay? The area is going to be, we are talking about ground base slab, then we add the sections of let me just confirm, the take is equals to 13, which was the area for all the base slabs combined. Okay, then we move to formwork, surface of the suspended slab. Formwork, the surface of the suspended slab is measured in square meters. That area we had already calculated, so it's equivalent to, the suspended slab is 10, so just equate it to that. Then sides of walls, okay? Sides of walls that we are talking about that we need to measure here are the two for the scam baffle wall and also the dividing wall. So in this case, we simply take equal to wall 1, we have an area, multiply that by 2, and then we add the dividing wall, that 4 multiplied by 2, okay? All right, so that gives us the area for formwork on the sides of the wall as indicated. Then edges of slab are measured. The formwork there is measured normally in linear meters. So if that is so, then what we'll do, we go to our drawing. This is where we have it. So the cover slab is meant to cover the entire stretch of the slab that we measured. So under home, go to linear tool, click on the first end, stretch it all to the 4 ends that you need to measure, okay, that way. Then click stop. This gives us 12.97 meters, okay? So we get back to our BQ. So 12.97 to the nearest whole number gives us to be 13 meters. All right, then quickly at first, then we go to walling of the septic tank. Walling is measured in square meters. So what we are interested in is how to arrive to that square meters. So what we'll do, we need to get a length. Okay, so this is where we have the walling. So we have the walling for the section of the manholes, and also we have another walling for the section of the main section of the septic tank. That is the masonry walling. So we start with the main section. On the main section, you notice the heights are varying. Okay, there's a section we have F1, and another section where we have F2. So the first step to getting the length or the area is for us to get the length. So is equals to, what do we have as the length of this particular wall? The dimension we've just measured, the 12.97, we can adopt it also for the wall of the main section of the septic tank. So we'll take the 13 meters, and then we need to now multiply by an average, because you can see there's some parts of this septic tank that is there are some parts of it that is higher, some parts of it that is lower. So an average of this should serve us just fine. So what we'll do in this case, while we are getting the length, the depth for excavation, we had measured and done the total depth. Okay, that is what I want us to refer to. So length here we have gotten to be 13, while depth in this case is what we are calculating next. So looking at this breakdown, 1.5, just to reiterate, 1.5 and 1.4, that was F1 and F2. Then we got an average of that. Then 0.2 was the base slab, which in this case now we don't need. Okay, so the only part that is going to be taken away is the 0.2. Okay, so we can as well just copy our working there and then bring it down here. Okay, and then we do away with the 0.2, which was for the base slab, and 0.05 as well, that was for blinding. So we have the average of F1 and F2, and then we add the 0.75, which was the dimension above the line, above the TWL line. So we have 0.75. So the height now becomes 2 meters. So the area for the wall of the main section, the area for the wall of the main section is length multiplied by height. That becomes 29 square meters. But then we have two parts. There is another portion for the manholes, because we are doing them all together. So for that portion, we'll just take the 3 sides. Okay, so we'll measure the 3 sides this way. So you click on that, actually not that point where it meets the other wall, go all the way. Okay, that's the end. Then stretch it downwards to that point, and then to this other point. Okay, so that gives us a total of 2.886. So we can take that to be it to be 3 meters. No, let's just take the 2.86. Okay, so this is 2.86, and then the height. What is the height of the manholes? Let's see. Heights we have actually measured, and that came to 0.75. 0.75. So you remember there are two of them. There are 2 of them. So so multiply the length times 2, we get that. and then the wall area gets to be 6 times that. Then we get the total, just add the area 1 and area 2, we get 33 square meters. So that gives us the total of the area for the walling. So that is 33 square meters. So extra overwalling for leaving 100 millimeter diameter holes. So these are provisions for the inlets and the outlets. So we just count them. It's only at this point and another one at this point. So those are 2. They are measured in number. Have it 2 there. Then waterproof cement and sand. Okay, so this is a screeding of the ground base slab. It's measured in square meters, and the area is equivalent to the slab, which we had already calculated. That is 13, equal to that. Okay. Then we have this other one, 12 millimeters thick waterproof. 12 millimeter thick waterproof cement rendering to soffits of suspended slab. Okay, so this one is equal to what we had already calculated. For the suspended slab, and that is 10. So you can see it has been taken from the 10 we had already done. And then 12 millimeters thick detour to masonry wall surfaces. So for the wall surfaces, we had already calculated the dimensions for the walls, or the area for the walls. So we just equate it to the 33 square meters. Then detour to concrete wall surfaces. So this one is the waterproofing that is going to be done for the scam baffle wall and also the dividing wall. So that particular area is equivalent to, we add that times 2, and then we also add this 4 multiplied by 2. All right, so once you're that, then we go to what we call the sundries. So that include the covers. Okay, include the covers. So in this case, we'll read, or we'll confirm the sizes that are provided for the manhole. So we have a cover here, 600 by 400 millimeters cover and frame. Okay, so we have that. So 450 by 600 millimeters manhole cover. So we do away with that description here, with steel handles. So how many manhole covers do we have? Looking at this, there are 2. So we have manhole 1 and manhole 2. So the number there is 2. Then 20 millimeters thick diameter by 300 millimeters long galvanized mild steel step irons with both ends built and firmly secured into wall. So normally this is just the access to the manhole. Okay, so normally you give provisions of steel steps from the top to the access to this lower part. So that mentions what we have here. They have been provided in terms of the diameter and also the length. So what we need to know is the number of such. So you can always do them at intervals of, let me say, 450 millimeters apart. So what we do, take the total height, which was 2.45, then you multiply by the interval of 0.45. That gives us 5.44. Then we round it up, you can get 6 number steps. Then 100 millimeters diameter UPVC outlet and inlet pipes. So these are the pipes that are used for the inlet and the outlet. So what we need to measure is just their lengths. So normally the provision is, we can always take the entire wall, and then we give an allowance to the entrance and also at the start. So normally we can take it quarter way from manhole 1 and quarter way into the septic tank. So that is an estimated length. Okay, so we'll take 700 and 700. Let's take 750 on one end and 750 on the other end. So that is equals to 0.75 multiplied by 2. That is 1.5 meters. So let's take 2 meters instead. All right, so that is the end of the estimation. But one very important bit that we'd also like to see is just keying in the rate so that we can see how much approximate cost of a septic tank is going to be. Okay, so the rates that I'm going to use here are my personal rates that I've built over time, and you might have your different rates depending on the location and so many factors whom you are buying from and so on. Quality of the items you're using will also determine the rate that you're going to use. So excavations, bulk excavations will do 450 per kg. I mean per cubic meter, sorry. Then we do the same for the next. And then loading and cutting away, say 250. Mass concrete, we can do 500. Then class 20 of concrete, we can do 12,000 per square meters. So we'll prorate, so 12,000 multiplied by 0.2, which is the thickness. Okay, so prorating means take the rate per cubic meter, then you multiply by the thickness in this case to convert that rate from cubic meters into square meter. So that is how you do that. I'll repeat the same for the rest, but then now I just convert according to the thicknesses. This is 1.125, and then this other one is 0.1, and then this other one as well is 0.1. Then assorted reinforcement bars. Reinforcement bars, at the moment supply rate is around, let me say, 140, but then plus fixing rate you can get it at around, say, 190 per kg supply and fix. Then BRC mesh, take 500. Then formwork we can take as well 500 per square meters. Then we prorate the ones for this one for the linear, so we multiply by 0.15. That gives you 75. Then walling, natural stone walling, we can do 1600. Extra overwalling, leaving 100 millimeter diameter holes, that one we can do let's say 200. Then waterproof cement, waterproofing of that, this one let's do waterproofing. Yeah, waterproofing is quite expensive, plus plastering, so let's do 1200. All right, then waterproofing again, so this is also 1200. This one as well is 1200. Detour to concrete surfaces, another 1200. Then manholes, 450 by 600, let's do 1500. Then these ones, a piece of them, let's say 250. Then diameter UPVC per meter, let's do another 250. All right, then lastly, let's get now the cost for this. Multiply the quantity times the rates, then we see how much we are coming up with. All right, then we do the sum of that. We just add all this section. Okay, that is our 95,000 so far. Brought forward, so we just equate what we've calculated, this one equal to, then in this case also we do the multiplication quite fast. That one comes to that. All right, Then summation, we now add both what we have calculated. You can start it anywhere, go up to that bit, close, and here we are. So this one in total comes to 263,000 Kenya shillings.